Welcome back to another glorious day in high season in Thailand, December 1st. The tourists are rolling in and the weather's looking good. But of course, I'm here sitting at my desk making a mess. And what I want to do in this video is instead of this clicky click digital button system to record which coin is going through, I want to move to a more realistic system that matches the way the existing one works, which is that the sliding thing that, the coin goes through and then magic happens and it registers the width of the coin. Now this is done by the little contacts, but what I'm going to do is use a fancy sliding resistor, and that means we can use it with any coin system in the world. All it needs to be done is calibrate it with each of the coins, and then the user can either select the currency or we lock it in based on the product and where we're shipping it. So what I did was I fabric cobbled up a little prototype board that is the same profile as this, and there's actually some what are those called, locating pins, and then screw holes. So this goes on here and is held in place nice and tight. And then I have this beautiful sliding potentiometer that I had to order from Japan. It's the only place in the world that has something like that. And you can see it just slides back and forth. It's gorgeous. And when I ordered this, I actually had to fill out a declaration of exactly what it was going to be used in. So I had to say it's used to detect the size of a coin in a child's digital piggy bank. That's the level of detail they wanted. I guess they're worried about parts going into missiles or something in North Korea. But anyway, so here we are. This is the setup we've got, and you can see that this little bit slides here depending on the size of the coin. Now what I need to do is design a new one of these, this part right here, in 3D so that it has a part that sticks up and then latches on to this arm. So as this then goes across, it will drag this little slider back and forth with it. It's not going to be the easiest thing in the world, but we'll get it working. And it's just a prototype. Then what happens with this resistor is we'll put a voltage across it, and then we'll use the analog inputs to the Arduino Due to measure the voltage, and we'll calibrate it for each size coin, and we'll detect the voltage that is read on the input based on a certain coin size, and then we'll give it a little fudge factor, plus or minus on each side. So next thing to do is to design a new 3D slidey bit. Interestingly, the slidey bit here for the coin is actually made up of two pieces. The spring fits in there, and they come apart. There's a top part and a bottom part. The bottom part is interesting because it's actually got a roller that lets the coin slide through nicely. So I want to preserve this. Then I want to make a part that snaps onto the top, comes up, makes a right-hand turn, and then fits onto the tab of the sliding potentiometer. Now, focus. It's got these little pins, which are very cool. So let's see what I did to make all this magic happen. Okay, so we're making a new part for the top half of the slidey bit. So I've got two bodies here. The first one looks a lot like the existing top of the slidey bit. There's the top with the spring holder. There's the diagonal slot for the coin. But I've also added a tab hole, and that's going to match up with the cross part, and that's what captures the tab of the potentiometer. Now, it's not pretty, but it's functional, and it's a prototype, and it does what it needs to do. I've also done the holes in the bottom, so it snaps into the bottom part of the slidey bit. Let's see how that works out. This is the top part that's going to sit on top of the roller, and that's the spring capture there. And it's going to sit in the little pins, but of course the pins are off by a tiny amount, and I don't want to break it. But let's take a look at where the top part is going to snap into. So this is going to go in this orientation. Then this part, which comes across and the tab fits in there, goes right in here. And one thing I've noticed is this printer really underprints the diameter of a hole. It makes the hole smaller than requested in the 3D design. But I managed to stuff that in there, although it's not great. I'm going to have to expand that. Now, the other issue is that little horizontal tab is too small for the pot to fit into in both directions, the width and the height. So, version 2, here we come. Okay, version 2, let's see how we go. Tabs in slots. Oh, look at that. That could not be better. And the spring goes in. Let's check the top into there. It certainly goes in. It's a little loose, but I can put something in there to stop that. And this bit goes in here. Again, it's got some up and down framing. It's got some up and down, but side to side is pretty tight, so that's good. Now, let's try and assemble it into this. All right, we're very close. If I hold this like that, everything slides back and forth nicely. The only thing is the top part is a little bit loose into the bottom part. There's a lot of play there, and it kind of gets hung up, and it goes sideways. So I think I need to make a little bit of an extension right in that black part that's highlighted in black that you can't see. But that needs to be a little taller right there. But we're super close. Okay, version 2 of the upper tab is working nicely. Now the pot is not soldered in, so don't worry about that too much. But we're actually tracking this across. I've got the spring in. I've got it screwed down. I won't screw it in too many times, so I strip the threads. But let's just do a test. This is the smallest Thai coin. 25 satang is a quarter of a baht, so it's about a quarter of 3 cents. So it's, just under 1 cent's worth. You saw the pot just slide over the tiniest little bit. Watch that again. That's good. Here's the 50 satang, about 1.5 cents. Good travel on that. Here's the 1 satang, the first most commonly used coin. All right, so we are mechanically sound. Well, as sound as we're gonna get. Okay, I've got the potentiometer soldered down, and I've got wires attached. I've got a ground, a plus, and the wiper. And I went to check the manufacturer specs on it to find out what pin to go to. Pin 1 and pin 3 are the top and the bottom, and pin 2 is the wiper. So that means this lug pin, pin 1, is one end of the resistor. The small pin, pin 3, is the other end of the resistor, and pin 2 is the wiper. Why would they even do it that way? I don't know, but let's check it out. I've got it hooked up to a 12-volt supply. This is with no coins, and then as a wider coin is inserted, the voltage goes up all the way to 12. Now this is going to be actually driven by 5 volts on the Arduino, but this is just a test. And the sensitivity is not bad. It takes a minute to come off 0 at the bottom, and then at the top it also takes a bit to come off 12 volts. So that much of a gap right there. From there to there, there's essentially no travel, or no difference, and there to there is no difference. But that's okay, because we're dealing with coins that are going to be in the active range. So let's hook it up to the Arduino. Okay, first baby step, we are wired up here and going into the Due. With the slider all the way at the bottom, we're reading 0, and the reading's going to be from 0 to 4096 because we have a 12-bit analog to digital converter. And as soon as I move it, there's a little bit of movement, and then our number starts going up. So there's just a few millimeters off 0. Then we're going and we're going and we're going, and we top out at 4096. And then there's just a little bit of no movement at the top of the scale. And we're actually running at the 3.3 volt input here. I tried it with the 5 volt input off the Due, but I got a lot of missing data. The 4096 entry was way off the top of the slider, so I think we were overdriving the analog input. It's working much better on 3.3 volts. So let's add some logic to see and capture the highest value, and then we'll start looking at coins. Okay, we are counting coins on the slider, well, kind of hard-coded anyway. This is back here, the serial port output. Focus. And I'm going to be displaying the analog value read and what coin we detected. I've got each of the coins theoretically hard-coded to be 500 analog steps from each other. So the smallest coin, the 25 satang, is going to be at the 500 value, and I've got it plus or minus enough that it should be fine. So let's go ahead and we'll scroll. Okay, I'm at 489. I'm going to scroll back, and we detected a 25 satang coin. Don't worry about that. I already had some in the bank. And if I scroll over to 1000, and then back, I detected a 50 satang. If I scroll to 1500, and back, I detected 1 baht. If I scroll to 2000 and back, that's a 2 baht. 2500 and back is a 5 baht, and 3000 and back. Well, that's happened before. That's a 10 baht. I'm not quite sure. Something in the software is frozen up, but trust me, it works. Next thing is going to be actually installing that into here and measuring the exact value of the width of each coin as we're actually reading the values. Okay, I've now mounted it back up into the actual coin holder. I'm going to reboot the Due. Again, very hard to see the numbers on the screen, but we're at the 0 right now, and we're reading about 22. I'm going to put each coin through and see what kind of reading we get, and I'll do it several times, and I'll take kind of an average of what the readings are. We'll see. Here's the 25 satang. So that came out through at about 514. We'll do it again, 493. We'll do it again, 469. I'll do it really slowly. 553. So it has to do with the sampling rate, I think, when we try and capture the peak. 491. Now I am taking this as a 25 satang coin, but that was purely an estimate to space the values out in the software. Now try a 50 satang. That's 975. Oops. 1047. 956. 1 baht. 1392, 1387, 1367, pretty tight spacing, 2-bot, 1895, 1859, 1848. Now we're getting into the big ones. Here's a 5-bot, 2467, 2432, 2462, very tight spacing. And it thinks it's a 5-bot just because of my sample data. And here's the big 10, 3041, 3004, 2979. So it looks like it's nicely centered around 3000. Good. Okay, so now I've got some real calibrated values. I'll put that in the software. I'll tighten up the spacing and the delta, or the plus or minus, around our theoretical perfect width. And then we'll see how we do. After much cutting of plastic, I've got the sensor mounted back in the top thing that screws onto the bottle. Only cut myself once this time. That's a new record. Do not give me sharp objects. Okay, tiny text. Let's see what happens. Here's the 25 Satang. Nope, that was the 50. So much for my testing. This is the 25. Yes. Here's a 1. Focus, you fuck. There's a 1. There's a 2. There's a 5. And here's the 10. Yes! And now for today's extra content, I have hooked up a small LCD panel, which will show what's happening with the piggy bank. It'll be up there in the product someday, but right now I just want to make sure that all the logic works. So first we'll go for the 25 Satang. Yes. And the 50. And the 1-bot. And the 2-bot. And the 5-bot. And the 10-bot. Okay. Well, that about wraps it up for this fun little experiment. We'll see if we ever go into production with this, but it's been a fun exercise. We've got 2 different methodologies. We've got the one that is hard-coded on the circuit board that catches a contact of a particular coin width. That has to be updated, new circuit board for every currency, new software for every currency. This version that measures a slider works for any currency and no software update. The user will be able to choose the currency from a menu type system, but it's a lot more expensive because of the slider is going to be an additional cost factor over just catching those contact points. So that about wraps it up. Thanks. Now it's time for dinner. Welcome, people who stayed to the end of this exciting video. I just want to let you know I've had a bit of an epiphany about YouTube, and it makes me sad. I've been asking people to subscribe to my channel and click the like button in the hopes that YouTube would recognize my channel and kick in a little ad revenue for all these goodies that I'm buying to help me with my little projects. And I realize it's all in vain. YouTube is caring less and less about the people who use its channel. Even the big boys and the big girls are having to go to something like Patreon for financial support. And I'm just not worthy of a Patreon following for anybody. So if you've enjoyed my stuff and you want to see more of it, go ahead and click subscribe and like if you like. Otherwise, just enjoy this picture of my beach here in Thailand and enjoy the rest of your day, and I thank you very much.